embedded system and computer vision and robotics, and along with the application level. And he handled many more projects, 3D scanning robotic mission and AI-enabled humanoid robotics and real-time temperature monitoring and alert system and the gas valve control and monitoring system and many more. He is also trained more than 600 plus students in the field of electronics and IT related domains during the workshops and boot camps and trainings. And he also trained uh, corporate professionals from prestigious companies like Carddeco.com, Reliance Jio, and Janssens, eBay, Ericsson, IBM, Dostik, IHHG, Genpact, TCS, Wipro, and Secretariat, Jaipur, and many more. And he also delivered 60 plus practical workshops and numerous sessions on various topics related to Internet of Things, artificial intelligence, and machine learning, robotics, sixth sense technology, image processing, embedded system design and manufacturing at different engineering and technical institutions until India, including IITs, Jodhpur, Dhanbad, Mandi, NITs, Kerala, Roorkela, Jaipur, Raipur, Bhopal, Agartala, and many more government state universities, along with central universities also, including private universities like BITS Pilani, Amity University, LNM IIT, Purnima University, JECRC, and many more engineering college also. Sir, I am very much happy to share with you. Please continue your session, sir.
Yeah, sure. Thank you.
Thank you very much, sir.
Well, I hope my screen is visible to all of you, and
Yes, sir. Yes, sir.
and a very good evening to all of you, whoever present and like listening to us in this session, and that is like expected to be on data science, especially. And my sole purpose of this session is all about like doing some hands-on stuff. I believe like a lot of sessions have been already conducted in this particular domain itself, and like one of the key topic we're going to discuss here. I mean, like not very theoretical angle, rather we will be going more practical over here. So like anytime if you ever feel like it's like I'm always you know a person who believes in if we do conduct any kind of session, we can make it like more interactive and more intuitive if you really do the things alongside me, because I am considering like what am I doing here on my screen. You can also do the code alongside me, right? And there are some assumptions I'm like taking up. Like you guys are a bit familiar with Python and somewhat the data analytics as well. So in that regard, I'm like going further with my thing. I hope I'm clear about the things. And in any particular point of time, anyone have any sort of like what is the agenda of our session is in this particular hour of time. We are dealing a lot with the particular domain named as machine learning and artificial intelligence. And so as my domain of expertise, we've been like doing it for quite some time now. But it's a big question. Like when I say, machine learning or, AI, these are the things which are revolving around all, the data only. So how we really, do that particular thing specifically when I talk about a specific problem, maybe, predicting what is going to happen next, or maybe like predicting what should I be like, sending up next or anything else. So such things could be done with the help of machine learning for sure. But for that, we needed some data, and we always needed some sort of approaches through which we could actually make a system model that can predict the things. So my like agenda, as I was talking about, is all about going with the classification, modeling, and machine learning. So I hope like you guys are a bit familiar with the things. What are the machine learning and what are the data analytics and other terminologies. So as like I'm going with this particular very specific thing here, classification modeling. And in that also, I'm going to talk about very specific one, that is decision tree algorithms. So this is going to be a completely practical session, but I just would like to give a very brief about this particular algorithm first off, like why we do it and why we call it like a classification approach, or like what is the classification problem itself. Right. So I'm just giving a very brief onto this, like a decision tree. The name itself suggests, we're going to build up a kind of tree for sure, and the tree is something which is built up deriving some sort of decision branches over there. So how we really do this decision branching, and when I do this modeling, what are the key parameters which I should really be like looking forward? Like as an application developer, I used to be doing a lot, for the corporate people, and they we used to have it like we know it theoretically what decision tree could be, but when we do it practically, we need to be like very clear on the things, how we should be really approaching and what my system capabilities are, and there could be like a lot more possibilities. I should be really knowing about those. So how does this particular thing really works up? And like mentioned it, classification modeling, but this is something which could be used for the regression purpose as well. And I believe there would have been like another session on this regression topic itself. So considering that fact, I'm going forward like classification, where we have some sort of data, and we get some data having labels for sure, but the labels are categorical. So when I have categorical labels, I would always be talking about like I'll be building up a machine learning model that for the classification purpose only. So how we really get the labels and what sort of problem statement I would be like thriving into, we will look after that this particular quick overview on this topic. So let me just try it a bit. Now, a second on this. What could I do? Yeah. So. Okay. So when I say tree and like decision tree, so definitely trees are meant with kind of structure, having a lot of branches. So as we build up here in decision trees, and that is something derived like a flow chart kind of view, not exactly a tree kind of thing, because tree is something where we have like kind of a base trunk kind of thing, and then we just bring up the branches. But this is more like a reverse tree, not the forward tree. We call it like reverse tree, going from top to bottom actually. And this is the main thing. Otherwise I would say like having some root kind of things, a lot of branches, and then in the end the byproduct, or like product I should say, leaves. So that is what we do here. But how we like derive this particular thing into the classification or maybe regression, so it could be like derive what we used to do our childhood days. I mean, like childhood means maybe like majority of you are from the BTech background. This is what I'm guessing right now. I'm not very sure on this. Like anybody like from any other background could also be possible. But we used to do some basic programming, and that time we all have learned simple if-else conditions. So decision tree is something that is actually going to give you those conditions where you need not to actually write those conditions. Rather, the computer or your algorithm will itself find out what could be the condition. And that's the interesting fact about this particular algorithm. And that's what I personally like. Like it should be like, how, amazing it is. Someone is going to tell me what sort of conditions I'm supposed to write for my if-else, and my program is done. That sort of magic it actually does, and that's how it really works for us. So like in this particular case, if I say like there are some people in the family, and we were supposed to find out if the person really likes the games, like video games probably. then I might be like categorizing them to find out the results or the outcomes, I should say. If like I say the people are old age, maybe they're not interested into playing the games. And so as if I just talk about like whether it's like a male candidate or female candidate, maybe they are interested more if they are male, and if they're females might not be interested much. So on the basis of this, we will be going for the decision building up, and definitely, how would I be deciding what could be the logic over there? That's something the algorithm will tell us. So how this particular thing really work up, and what are the key terminologies I should say we will be having up here, like root node, as I mentioned, from which the branches, or I should say the tree will start building up. Then we might have some splitting of the data, maybe like on based on some conditions. Then we further split them, building up another decision node, maybe more decision nodes, and then in the end I would say the final block or like final substance of my splitting could be termed as terminal node or leaf, I should say. So these are like key terminologies whenever you'll be like dealing with the decision trees. So like root node, splitting, and decision nodes alongside the leaves. But apart from these, we have got few more terms like pruning. We have got branches and subtrees, and the parent-child node. So these terms are like quite popular when I talk about the decision trees. So not much very complicated ones, not as like any rocket science, I should say. Like very simple terms, flow chart kind of structure, and we just break them down until we get the final or outcome that we are really desiring for. So that's how they have given us the terms. So it could be like any particular approach for this particular way. Like in this particular example, if I'm having with me, I've got like some numbers 1 and 0. So I'm supposed to segregate them. Like I want to segregate all the ones aside and zeros aside, and that is what like if I do the visual inspection, then in by visual inspection it is quite easy for me. I would be saying, okay, these two are the ones, let's put the others 0. But the computer actually doesn't know, so we will be telling the computer by some logics or maybe some attributes. What we say attributes could be like we have got a few having a red color, and few are having the blue color. Attribute could be like we have a few having some underlines, and the others are not having that. So the basis is like the attribute for sure. So I might decide one attribute first, maybe the color. So my question could be like, is it red? If it is, then just segregate them in the other side. We'll be getting the blue ones. Then after what I see in the blue ones, they are like further, they're the like terminal nodes. They are the leaf of my data splitting, because this cannot be divided further. I do have only couple of attributes, the color and the underlines. So both the things are like already done here in this particular data set. So I will not be, splitting it further. That's how my algorithm will be doing it. It will not be, just going and just breaking it down for a random purpose. It would be definitely searching for some attribute. We found it like single attribute color. Single color is here. When I talk about the underline, so without underline structure is here. But what about this one, 110? I would be saying, okay, let's find out the other attribute now. That is underlined. So do we have anything underlined? Then you can just put them in the left side. And if they're not, then put them the right side. So again, these are like my, the outcomes of the leaf node terminal nodes. Like further, we cannot break it down. So this is something like whatever I've shown you here is actually the fundamental behind building up a decision tree. Like whenever I will be building up any sort of tree, I would be actually interested into what kind of parameters or like features we have, because in data science the data is everything and data is beautiful, but when it is beautiful we need to find it out. So we found here like we got some attributes down, we got some colors and underline sort of things. Based on that, I divided. I could have gone like the first decision could be made on this part, like if it is underlined or not. That would also be the way of doing it. But how would I like decide like whether it is going to be the color first or the underline attribute first? we need to be definitely clear on that part as well. So let's just get through with the steps, and then we will talk on these things further. Definitely, the whole data set that we'll be patching up first up, maybe any specific data set. Let's say I have one and I would like to show you right here. Uh, got a very common resource here. I mean, this is quite popular platform. I hope you guys are familiar with this particular thing. If not, then let me just mention it. This is termed as Kaggle.com, and I mean, this is quite famous platform where we get the data. It's a plethora of data, I should say. And here you will find all sort of things. Like if you have ever have any kind of thought, like I want to work on this particular domain to explore data science more, or I want to do, some sort of practicing or hands-on stuff with my, again, like data analytics, maybe machine learning, and so as I'm telling you, this is the place where you should be coming up and just explore it. And how to explore it is pretty easy actually. First up, you need to create your account, and that's too easy. You can go with Google, like sign in with Google. And I'm guessing you guys might have created the account already on this. If not, then you can do it. The Kaggle.com, Kaggle. Here we see like a lot of data sets, competitions as well. Like the BTech people, BTech pursuing people rather, and so as like definitely the research scholars, they all need some data sets, and they will get like some competitions as well where people actually do earn as well. So I can see here a lot of you know problems around, like Twitter US airline sentiments, or like popular data sets. If I say heart failure prediction data set, customer personality analysis, and lot many other things, I should say. So I am interested, maybe like any particular problem statement. We could choose any of those, but instead of making you guys rumble around, I would just say you could just follow one link there. Uh, like this is my profile over here. So I could just drop that in the chat box. You can just hit that up. You know, Kaggle.com/sunamps. That's my profile. So if you get into this particular section, I hope my text is there. Yeah. So here we get, by default, the home will be opening up. So you need to be dataset section. And from one of these datasets, I might be interested in one. Okay, I might be, opting for this one. This is perfect case of classification where we will be like, doing a lot of hard work to obtain the results, and definitely um, implementing the classification modeling as well. So what sort of data I've been provided here? Let me just tell you about it a bit. Like there are approx 16 attributes, and this is entitled as tour package prediction. So what can be the prediction here, like we are expecting really? So this is something, it could be termed as, like you guys might have seen some popular websites in India, like Tobago, Yatra, Make My Trip. These like platforms have been doing great with their efforts, definitely. And what they really brought into the picture, like earlier when we used to travel through the flights, it was really tough to find out the things. But nowadays it's like whatever airlines it is, you just search on maybe like Yatra or Make My Trip, and you will find like the best or the cheapest price solution in terms of the duration as well. So a lot of comparisons are like already happening up, and on the basis of that, those platforms are also suggesting us like this could be like better for you, or maybe like the user feedbacks, and maybe like the activities that we are thriving into, like we are searching for some flights on a regular basis maybe. So they do like ask for opting for the newsletters and all. So all these things are actually doing a lot of machine learning these days. It's not a bare website like having some airline structure or data. It's quite you know quite a lot beyond our imagination, I should say. That sort of effort they've been putting into. So in this particular case, what is my problem statement, I should say? Not mine, actually. This is a very common data set available on Gaggle everywhere. And like I have just kept it for like very general purpose, so everyone can use this. So I'm just sharing the link again. Yeah, that's the one that I'm talking about. So in this particular data set, like there could be like a tourism company, and they are having some, two packages, and what they are interested into, they might be having some visitors or maybe some, clients. They are like existing clients, so they wanted like the clients should be opting for their specific tour package, and every company actually seeks that thing, the business to be growing, and they want clients to be like buying more products from them. So that was the goal, and the goal was pretty specific here. Like we have got maybe like a few tour packages, and I just want to find out if the user will really buy that or not. Like whatever tool package I'll be offering to the client, will he be like buying it or not, and what is the basis of asking my client like will you be buying it or not. Could be like some calls, or maybe some cold calls, or maybe some marketing and other stuff. So I'm like investing a lot of money into that to find out my potential customers. So I'm really like so much keen on this. If I could really find out like my user was really interested into something, like if I'm asking my telemarketing or telecalling team, like you need to be contacting these clients. So if I could drive into some uh, you know uh, filter out there based on my past experiences, it would be great help. Like it would be like definitely proving the conversion rate quite higher, and that's like the every company's goal. So here in this particular problem statement, like I mentioned, we are thinking of finding out whether the customer would be the potential one or not. That's it. So potential one is like that's yes or no. So that's why we call it a classification problem, because we are going to find out maybe like between two things only. It could be like more than two as well, but right now this is between two only, yes or no. And for that, I've been provided with total 16 parameters, attributes, whatever we call it. So when I see here, I just, let me just zoom it in a bit. Okay. So I just see it here, customer ID. That's, it could be like unique for anyone. Second is product taken. So whether the customer has purchased a package or not. So that is the another point I do get here. The customer like was asked for a product. It is like the past data that I've got with me. So the customer was asked for the product and he or she actually bought it or not. That's what sort of information I've been provided here. So that means my data is labeled also. I thought of it as a classification problem, and that is labeled as well. That means I've been already provided the product was taken or not. And that is the basis from where I do decide, like I'm supposed to go with the supervised machine learning, and that too with the classification modeling only. So now I'm done with that part. Like opting for the classification algorithm was the requirement here. Now, what are the other things that will make me, decide which algorithm would be working up here, or like I was talking about the decision tree. Not done with that yet, but still, like, do we have any other way of doing it, or like other stuff? So there are many questions, I should say, that were required to be answered. So let's go one by one with each of the question here. I mean, like I just decided on, got the data sets, and that sort of things we have. Classification is required here. Now the other informations, I might just have a look at quickly over these. Like age is provided, type of contact, they were called up by the company, and maybe like they were invited, or like they inquired themselves which city they were actually living into, the customers, and like the tier of the city actually means like small city or like a bigger when I talk about in Indian perspective, it's like a Bombay, Delhi kind of city, or like That's what we call a tier 1, and tier 2 could be like Jaipur, Indore kind of cities, or maybe like tier 3 cities. So genders is there, number of person visiting is also there, and the preferred property, like what kind of thing actually they were looking up. Marital status could be another factor of the visiting customer. Number of trips the customer is actually doing on an average per year. Do they have the passport? Do they own a car? Number of children if they are bringing up together, to, or like what's the designation, and their monthly income. So from my personal point of view, I see here a lot of parameters are quite relatable here. Like if I am the one who will be like, buying a particular tour package, so definitely my income structure matters here. If I'm earning like, let's say 20-30K per month, it might not be like going very frequently with my tour plans. But if I'm like earning maybe like more than 150K or so in a month, I might be like interested. Let's spend some time with the family as well, or maybe not. So income and like having a lot of other special attributes could be like quite helpful and useful here. So I have got the parameters. What am I supposed to do now? I've been provided with the data set like here. So I will download this file, and then we will just take that into our Jupyter, and we'll talk about what decision tree is going to do with this, and we'll literally do it here. So let me first download this. It's having some real data. Okay, done the downloading here, and I will make sure that is into the right folder. I hope you guys are you guys are familiar with the Jupyter.
Yes, sir. We are familiar with Jupyter, sir.
That's great. So I'm just taking up my file here. I've downloaded that one, and I've created a folder on my desktop. Just bringing up the file, and in my Jupyter lab, actually this is Jupyter lab. Many people actually having less idea on this particular thing. People do work on Jupyter notebook instead of Jupyter lab. Jupyter notebook was a little older version of this particular tool, and Jupyter lab is the newest one. If you are not sure how to run this particular application, I can just tell you again on that. Like let me just show you live on this particular case. On my start, I can type anaconda prompt. That's like the prompt symbol I'm using. And from here, like I see, it's having certain location right now in my users folder. So I could ask it, can you please get into a particular location using the cd command? Let's say I wanted to get into the desktop, and maybe like this is the another folder I have already created here. So this is where I went into. Now I thought of I should be running up the Jupyter lab. So this is the way I could do it. Jupyter Space Lab. If you wanted to get into the Jupyter notebook only, then you could do it this way. Jupyter notebook. This is the command line interaction with this particular tool. So like I'm using Jupyter lab here. Nothing much different. There are little more shortcuts I'll be getting in my lab instead of notebook. So that's it. So I have done this thing. Jupyter lab already started. It opens up like this. It's having a little file browser in the left side only, and I've got a launcher right up here. So now I'm doing it for you, and just created a new file right here, and just zooming it in a bit. Okay, first up, renaming my file and going with the class invitation with decision tree probably. Let me just create a short name here, DTOL. So I've renamed it. All right. So first and foremost task, I'm thinking of bringing my data set into my playground, and that's my coding file, right? So how would I be doing it? I would be needing certain libraries, and I'm expecting again You guys are like bit familiar with the names here, NumPy and pandas. I'm going to use pandas throughout. Maybe sometimes I might need this NumPy, otherwise it is not necessary. So I can omit it right now. So I'll go straight away with the pandas library. I've done it. Now I will load the data. So this is how we do it. pd.read csv, and that was my file name to the packages, I guess. Yeah, it is. So as I did here, and it just got loaded. Now, the very first step, whenever I bring up a new problem statement alongside, I need to be exploring my data. Like we had a quick look on the Kaggle set, yeah, but now I would be very much interested into the file that I have read here. I should be knowing about it, and that could be done through some basic ED, I should say, basic exploratory data analysis, what we call it, data structure, or that could also be termed as. So I'm performing a basic ED here and just putting up a comment on this, and how we do it, the data structure I'm finding out. First could be the information. Actually, the data set is having 20 columns. Like there were 16 and 4 more columns around. So this is having 0 to 19 total, 20 columns in here, and we've got 4,888 entries in total. So number of rows are 4,888 and number of columns are 20. This is what the data structure been provided with. And what else I can see here is like all the columns, and I could sense here there are a few missing values as well, missing data. There are quite a few actually. Duration of pitch, number of follow-ups, preferred property star, number of trips. So a lot of missing entries out here. And other thing that I can sense here is like there are numerical stuff as well as some, string or text stuff as well, termed as object here. So I'm very much interested, like different kind of data here. So I need to be putting a lot of efforts to, deal with those. So let's see what could be done here. And now going forward with the next step, that is, how does my data look like? I'm getting some sample entries here. So instead of head, I'm putting up sample, and like some 5 random values are fetched up. So in customer IDs, I could see there are a lot of numbers only, and they look like, maybe some sequential numbers or unique for all. Product taken is like 1001 and sort of things. Age is a numerical figure, what we have got here. Type of contact is actually, seems like here some categorical information. Company invited, self-inquiry or so. City tier is there. Duration of pitch is numerical. Occupation is again like something I'm sensing. It's a categorical stuff. And gender is again the same thing, categorical stuff. Number of person visiting, 2323. Number of follow-ups were taken for that particular client. Product pitched, so that also looks like categorical stuff to me. And then comes the preferred property star, that should be between 1 to 5 only. Marital status, married, divorced, and unmarried. Seems like that's also categorical here. Number of trips, they do go for in a year on an average. Passport, do they have the passport or not? Which satisfaction score that they have given. They do they own car? Number of children visiting, designation. That also look like some categorical information to me. And monthly income is like another continuous numerical stuff. So I could see the data. This is what we call like visual inspection we've been doing. And there could be one more step that I should be doing before getting deeper. I could go with a basic statistical overview of my data. And here I could see something that could be helpful for me. Let me just do it in the slightly different way, include all. Okay. So this is something where we see customer ID, and they're going to be unique. I'm telling you, this is definitely not useful at all. Product taken, here we see the average value is 0.18. From this particular figure, I can just tell you one thing here. Like out of 100 people, only 18.8% people have taken the product. That's what I can sense here, because the values were between 0 and 1 only. So very less people have taken the product. Rest of them were like not interested. Age is on an average, age was 37.6. Type of contact was like self-inquiry was the maximum one, and the other one was like company invited. So majorly they were like self-inquiries. So they inquired themselves. Still, the conversion rate was quite low. So that could be another one. Another very important factor here. Out of 4,888, 3,444 were actually self-inquiry. Then comes the city tier. I should not comment on this. On statistical point of view, duration of pitch is like 15 minutes on an average. Occupation is like 4 different types of occupations are mentioned here. So salaried is one of them. It's like the most used here. Gender, 3 genders. Maybe something is missing or something else is there. Let's find out what is the case here. Why do we have 3 genders site up? There could be more possibilities, but let's just check it out. What is the case? Number of person visiting, 2.9 on an average. Number of follow-ups, 3.7 on an average. Products pitch, there are 5 different products they have launched up. And the preferred property star, 3.5. Marital status is like 4 different statuses here. Number of trips, okay, on an average 3.2. Passport, 29% people having the passports. So not everyone is having passport. Those who are having the passport were quite less. And pitch satisfaction score is like 3. On car is like 60% people having the car. Number of children is like 1.18, and there are 5 different type of designation. On an average, we have 23,000 monthly income. So one function gives us a lot of understanding of our data. That's quite really helpful. Now I'm interested into finding out like various things. Actually, I need to be working a lot on this particular data set. This is quite effort taking thing, but still we will try a few things here for sure. Then we will talk about that decision tree once again and we'll deploy it here, right? So going with this, I'm very much interested into finding out what was the missing data. So pd dot is null is what I'm hitting up. When I hit this with my df, it gives us this data, and here we go. It tells me the number of missing values, and that looks like that's very late actually. Missing values. So age is having missing values in all the other things, so I am more interested into finding out the percentage actually. So making that into percentage form instead of the literal values. Okay, so around 5% data is missing in duration of pitch. Rest others are like quite less. Age is also 4.6%. So that's like the number of percentage, I mean like percentage data missing in my columns. If I'm stressing this particular point, because when we have missing data, we need to be treating that a lot. So that's one of the very key aspects we got to know here. What could be the other one? Definitely the categorical columns. So I will be going through like basic data pre-processing here first up, just to deal with these missing values, and definitely dealing with my categorical columns. Then we can think of like my data is ready or not, because whenever I say I'm interested into machine learning, there are certain steps that we always need to follow. What are the steps? Let me just draw them up for you first up. They look like you would be getting some data that we already have got right here. Then we need to pre-process it. That's what I'm talking about. We will be pre-processing it, and as soon as I'm done with my data pre-processing, I would say my data is prepared. Data preparation. So data is prepared, and then we divide that into 2 parts. One could be like the training set, and other one could be the validation or testing set. So training and testing data. That's what I will be doing later on, not right now. On training data, we will be like asking our model to get trained. So building up the model and then forming some sort of evaluation. That's what the very general approach whenever we build up a machine learning model. So that's the thing, guys, we will be doing up. So this is very important step. Like many people talk about machine learning and they get stuck into the algorithm part. Surely you need to know that, but the pre-processing of your data is very, very important if you really want to build up any machine learning model. Because in like particular case that we are having here, that also is requiring lot many stuff which is supposed to be dealt here. So let me just do one thing. First up, I'm clearing my own screen. Okay. So the missing data entries, and along with that, I would be saying I should be knowing the number of uniqueness or like unique values or like categorical columns, I should say, in my data set. So how would I be doing it? I would say df dot unique, and I should say this is print, and in my print I'll be calling it something like this. So I just asked it the number of unique values for each and every column, and this is what I got to know from here. Like in my data set, customer ID is having all the values as unique. So as I was telling you, if my data is having all the data values as unique only, then it can never be termed as I should not be like stating it like this actually. Rather, I should be saying this is a kind of information which just shows the unique identity. It's not having any significant impact on my decision making. So I would say it's having all unique values and having no impact. As I could understand, this is like ID only. So I would just omit this particular thing. I would never asking it. I would be never asking it to be used up. So this is something in my data pre-processing. I would say it should not be considered. Apart from this, I would be like seeking a product taken is a categorical thing. That's fine. Type of contact, city tier. So the number of parameters having approx 4, 5, 6, or 3 like categories in total, number of unique values in total. I would be putting all of those into categorical columns. Rest of them, I would be saying they are like continuous columns or maybe like some simple numerical columns, I should say. So that is what we'll be doing up, and that's what I'll be doing in certain way. Categorical columns would be type of contact, city tier, occupation, gender, number of person visiting, number of follow-ups fetched, number of trips I can avoid here if I wanted, but 12 is good enough to go with that. So okay, they all look like categorical to me now. So that's my categorical stuff. And if I say continuous columns, then it should be duration of pitch, age, and the monthly income. So I will be taking those columns only: age, duration of pitch, sorry, so duration of pitch and the monthly income. So I just segregated them because I just wanted to have a quick overview of my data once again, like if my data is, depending upon on certain parameters or not. That's what I'll be thinking of. Not really necessary to do when I say like doing classification modeling. My algorithm will be doing the major work, but still I'm always interested finding out like what is the problem, what is the case there. So how would I be doing it? I would be simply asking it for, let's say, cn cat calls all the categorical columns. Do one thing for me, just print the value of C, which column I'm talking about, and just print a simple separator here, maybe like this, and then tell me, very important thing, out of my column C, what are the value counts for each? So here we go. Type of contact. In that we have only couple of categories, and all the number of values present of such categories are here. City tier is fine. Occupation, salary, small business, large business, freelancer is fine. Gender, okay, that's a problem here. Female and female. So it's a typo, and the typo is like more than 150. So I need to be correcting it because it's having only couple of categories. If it's a typo only, that is what creating it has like 3 different categories here. Other than this, what we have here is number of person visiting, it's fine. Number of follow-ups is fine. Products pitched is fine. And the preferred property star is like 3, 4, 5. Marital status is like married, divorced, single, and unmarried. Now, why is this single and unmarried? Okay, we can consider it. Maybe if you really wanted single and unmarried, we can, uh, you know, club them up. But if not, we can leave them as it is. Other than this, we could see number of trips on an average. Like some people are having more than 19, 20 trips on an average in a year. Passport is fine, pitch satisfaction score is fine, own car is fine. So I think all the other things are fine except this particular column, gender. We have female and female. So that need to be treated for sure. And that's what we'll be doing here. Other than this, we've got a few more columns, that is the continuous columns, age, duration, pitch. And they're also having some missing data. We'll be working on that. But when I say missing the continuous columns, what could be done on those? We will see that thing as well. We should be doing one more thing here, that is talking about the product taken. That's my label column actually. I say value counts for the label. Those who haven't taken, they were 3,968. Those who have taken, that was 920. Now, what I'm supposed to do? I will be firstly dealing with this particular column named as gender. How can I do this? We've got various ways of doing it, but in my pandas, we've got one function named as lambda. In fact, that's like Python's feature, and that lambda can be incorporated into apply function that was given into pandas. So I would say, please get into the gender column and apply a particular process to the lambda. And what's the process? I would be saying, like, you will be getting some sort of input and check it out. If that input is actually like this, please replace that with female. Otherwise, keep that as it is. So that's my, quick trick, I should say, the lambda expression I've used in here. And it is also provided with conditional comprehension here in the Python. Where we say if condition, then please do this. Otherwise, else do this. and that's my input provided through a function. And apply actually does what? It will be going to each and every row of my gender column, and then will be doing the things for me. Let's see what really happens when I do this. It generates another data column here for me named as gender. So I would be asking it, please update my existing gender column with this new one, like this. So that's how I am actually treating the gender column. Now, when I talk about this particular thing, as in like gender and doing a value counts here, it would be giving me a couple of categories, only male and female. So that goes well to me. It's just 1972 and that's 2916. So that's what we could do here. Going with the other factor, that is my continuous columns, age, duration, pitch, and monthly income. So that could also be used here for some sort of data interpretations. So let me see what could I really do here. I could go with a graphical visualization here, and for this I can ask it for CN continuous columns, continuous calls actually. Just do one thing. For graphical visualization, we require data like data visualization libraries, and I'm bringing up now, going just top of my code, asking it, please bring up the matplotlib.pyplot SPLT, so as I'm expecting cborn as SNS. So fetching up a couple of libraries here, matplotlib and cborn. Heading down here now and asking it, can you please generate, let's say, SNS dot this plot of BF's column C. Now this is what I'm expecting for my data, and I would be asking it, please show that graph so we can move further for the other graph as well. Let's see what really happens. It's just generating all the graphs, but alongside some warnings actually. And it says the this plot is deprecated, and that's why we are required to use a this plot. So it's like, different column syntax actually, I should say. So here it requires data and XY. So I am actually providing a data now. So X is C. Let's see. That looks good. But it's not actually stating. Okay, it's there. So when I talk about the age column is actually having a distribution, like majority people are having an age group between 30 to 40. There are few like less than 30 as well. There are a few more than 40 or 45 plus as well, but majority people are into this category only. That's what I could see from this particular graph. So as when I talk about the duration of pitch, so duration of pitch is also suggesting me majority of people been actually talked around I guess this is 7 minutes or so, 7-8 minutes or so. Many people. There were a few cases where we can see more than 2 hours been spent on a particular person on a call. This is an exception, and in statistics we call it like outlier. So it could be a case, but not always. So, and what we see like monthly income, majority people are having it between 18,000 to 40,000. I mean, like every data set is my between into this on, but majority are between 18, 19 to 25 or 27 per month. There are some outliers here as well, like very less points and very high points. So in total, it's like my data distribution, basic data distribution, I should say. I've got to know, like these are the columns, these are the parameters rather. Now I'm interested, like I could see here some, data that's like, categorical. If I do compare these information with my some continuous data That could also drive me into like more conclusions, more understanding. But since we have that thing directly available, like the product taken itself is a categorical thing, so I can simply compare my stuff, all these things like this plot and the other stuff with that. So let's see that. Let's see what really comes up. And do not show. I'm setting up little grid here. Okay. So what comes up here? Product taken. And the product taken or not taken, is it depending on age or not? This is what I'm trying to figure out. Like if I'm thinking of deciding the factor on the basis of age, is it really affecting or not? So those who haven't taken the product, they were slightly of higher age. That's it. That's all I could see here. But it's not drastically, segregating the things. It's just having a slight difference. Those who have not taken the product with respect to those who have taken the product and their ages. But when I talk about at the same time duration of pitch, again, this is not affecting too much. Those who have taken the product, that is like also having sort of similar sort of duration of pitch. Those who have not taken or taken, both the cases actually. But when I talk about the monthly income, here also I could see those who are having like higher income, maybe they're not interested. Those who are having less income, they're interested. So this is like quite of interesting factor here. So through this box plot, I could just see multiple parameters around. This is a bit of statistics, I should say. Like this is the median at 50%, I should say. This is 75%, this is 25%, and these are like the quartile points, like the higher limit and the lower limit. So that is what like we could see from this particular case. Now I'm interested, like what about the categorical stuff? If I do compare the categorical data with my, I should say the product taken or not, what is the real outcome of this? That's what I want to see. So for this, I will be doing very simple plot. That is the count plot. So for C and cat calls, I would ask it, please do that C1.count plot for me, where we will be getting x equals to C and data equals to DF and having a hue of product taken. So going with the plt.show, and now what I see here, number of people those who have taken or not taken the product with respect to their type of contact. So those who made self-inquiry and not taken the product and taken the product. So I can see here is the ratio is, I mean, not much different. Those who were like company invited, I can sense it's not making much impact in that. When I talk about the city tier, that is also not showing much impact, but slight impact is here, not very much. But when I talk about the occupation, this is, affecting it. In what sense? Maybe yes or no. Gender. That's also like similar kind of ratio. And when I talk about the number of person visiting, those are taken or not taken, there's no drastical segregation that I could just tell you, like simple visual inspection on this graph. So just showing the counts. But I was very interested if there could be some drastic difference. I could just really point out. Here we get. Hello. Okay. So here I could see some drastic difference, like the product pitched. In the product pitched, I could see the parameters like the deluxe, the product they have pitched up. So people were very less interested into it.
ठीक है सर अपनी शर्तां नाल ही काम करना चाहिए इत्थे जेड़ा दबदा है ना ਉਹਨੂੰ ਹੋਰ ਦਬਾਉਂਦੇ ਨੇ
when I talk about the basic one,
Shruti ma'am, please mute yourself.
बाकी जो भी हम काम करते हैं दूसरे दिन पेमेंट लेके एडवांस ठीक है अब सबसे बड़ी बात है मैं 5 day max को 5 साल तक है पूरा
Shruti ma'am, please mute yourself.
और सब ठीक है तो ये हमसे काम होता है
I think admin can do this.
बता क्वालिटी बनी अगर ऐसी बात ये तो बता सेवा मैनेजर बोला था कि वो दिन पार्टी जाएंगे और वो गए तो उनको
निकाला है
यस
प्लान कालन दी भी काम इत्थे वाधू ਹੁੰਦਾ ਹੈ ਲਿਖਿਆ ਹੈ ਨਾ
अगर स्टूडेंट भी होए मैं कहते मजबूरी की सब एक बात बता हर डिपार्टमेंट के अंदर का आईटीसी मेंबर
Okay, let's just try to concentrate on this. What I was talking about again. The basic package that they were like proposing to the customers, that is having the most the conversion rate here in comparison to the
क्या हुआ था उस दिन इन्होंने
other
आप
product.
सीएससी ग्रुप में हो ना एक दिन इन्होंने सिर्फ एडमिन्स को है ना किसने किया सौरभ ने किया और उस दिन सौरभ ने सबको कर दिया किसको अलाउड था किसको लिखना
Do we have admin connected with us? Yeah, now finally it's done. Thank you so much. So focusing back on the thing. So what I was saying here, we could see a drastic difference. The basic tool package was like having the very high rate of conversion in comparison to the others. Like I could see the graph is having around 1300 those who were not taken, and approx 550 people those who have taken it. So out of approx 1800, it was around I should say 45%, 40% approx the people have taken it. But in the other cases the issue was different. And if you remember, like there was 18% people those who actually bought the product. So if the customer was actually asked for the basic tool package, there were more chances of the customer getting converted into. So this is something I should say like could be a decisive factor, but not the only one. We could see like we could expect more parameters down here. As in if I say like the customer was interested in the 5-star, they were having more chances of getting converted instead of 4-star. You can see the difference. And when I talk about the marital status, okay, the customers those who are single, they tend to get converted easily. Don't know why the married people are not interested into buying the tool packages, but the single people are quite interested into that. And whereas the people those who are unmarried not very much interested, don't know why. So when I just scroll down further, the number of trips they do on an average, not having much impact. I should say it's like having a similar kind of view. The 4 and 5, the people quite much same. When I talk about the people having the passport, now that's again very decisive factor. Those are having the passports. It's around out of the 1500 approx people, it's around 500 people have like taken the product. So here we have got a very good success rate if the customer is having the passport. So all this what I'm doing here is a visual inspection just to find out the logic, like what are the decisive parameters here that will make my things to be get predicted. And this visual inspection could be carried out further, like with the other parameters for sure. Like I could just scroll it down more and the other parameters. Here also, this is quite important. When the customer is actually having a designation of executive level, they are more, into the case of like getting converted easily. The VPs and the managers are not much of the conversion kind of people. So these are little inspections I've done, and this could be like carried out in numerous ways. There are a lot of things, a lot of possibilities for sure. I've done a very few here just for mere understanding of the terms. Now, like we have got some major problems here. The problem was like the missing data first up, definitely, and the other problem could be like the categorical columns that were really required to get converted into numerical, because in machine learning models, like whatever kind of data we have, we require our data set to get converted into numerical type only. Then only it will be working up. So this is the other thing I'm always supposed to do. So let's do this like one by one. Firstly, I will be thinking of doing some sort of missing data treatment here. Now to do this, what should I be doing? I mean, like there are again like number of ways of doing it. One of the very ugliest way is I could simply ask it, please drop those NE from my dataset. This could be the thing I could simply avoid. But this is like definitely we should know. If I just asked it to drop all the columns, or sorry, all the rows, those who are having actually missing entries. So out of 4,888, I would be like left with 4,128 only. So this could be done. But we are here actually, paying a very huge cost. We are losing a lot of columns out right here, and that's something we will never expect. We will never be doing if it is like too much. If I would have had like 5-10 rows or so, I could have easily asked it to drop them up. But right now, this is not the case. It's like a very good number that I've lost. So I would be like expecting somebody to be like dealing the problem for me. So what I'll be doing, I would just ask it to treat the missing data, and for that purpose we've got like some missing data imputers, and for that library of ours, a couple of very special function. Let me just tell you about it. From sklearn.impute import knn. This is like a machine learning based missing data treatment. Like we haven't done any like sort of work yet, but still this could be used up for just predicting some missing values, because removing the missing values could be like easiest solution. But if I do remove the data, I'm losing a lot of data actually, in simple lines, and that's like losing the information that I don't want. I want my information to be there. So I would be going with a safe option where we just fill in the missing entries with some sort of dummy values, I should say, which are not really affecting my data. That's what I could say. They would be simply filling up by certain values. Those could be like just saying if it is having a certain mean, that is not going to get affected. Or if it is like having a certain class, I might be like just distribute the even number of data over there. So that sort of things we could try, guys. And let me do it first up. And before that, I'm supposed to do one more thing, because we have categorical columns and the KNN imputer is not going to work over it. So I would first do the dummy data for my TF. What is this? This is going to just tell you about the number of columns those who are having categorical stuff, they would get converted into encoded versions, and it would be like this. The marital status, for example, if that was divorced, it would be having 1, otherwise it would be having 0. Earlier we had marital status as a column which were having like 4 different values: divorced, married, single, unmarried. So instead of 4 different values, we converted them into 4 different columns and just mentioned 1010 kind of stuff into them. And for that, we had a one-line solution: get dummies. So it is ultimately a solution through which I have dealt with the problem of categorical columns. That increase the number of columns for sure right now. Alongside that, I would be removing the useless columns that I really found initially, customer ID. So for this, I would be happily accepting it. I mean, like removing it here itself. df.drop, or I could use a simple line, del, delete df, and the column name is customer ID. So I've removed the column and now asking it. So in total, I've got 35 columns. Out of those, the one is product taken, other one are like my features. Now asking it, please impute my data, all the missing entries that you could see here, please remove those. And this could be done to, I'm just calling it dfi imputed, and we'll create a data frame once again after imputation. And this process could be done quite simply by saying it KNN imputer, telling it number of neighbors. This is one of the classification algorithm, and very old algorithm, I should say, and asking it for the fit transform on my data, that is df, telling it the columns information has to be the df's original column names, and that should be done here. Okay, so what we've got here, definitely all my entries. And what is the advantage of doing this particular effort? The data imputation actually fills up all the missing entries. So instead of removing the entries, I just preferred imputing some dummy entries into those, and those dummy entries were actually predicted by the KNN approach, that is itself like a machine learning algorithm which predicts the values, and that is dependent on the number of neighbors grouping. It worked up here, and I could just see my entries are like having no missing values right now. Now I'm done with this stuff. I'm all interested into applying my final effort, like building up a machine learning model, and that too would be with algorithm. So for that, I would be doing the data preparation, the final data preparation. This could be done by bringing up the training set and testing set, and that can be done train test split function. Where do we have this train test split? This is going to randomly split my data, and I'm importing that function first up from sklearn.model_selection import train test split, like this. Now going back here, asking it train test split, but which one? So I would ask it, let's say we'll be going with X, that is having all the attributes. So it will be dropping one of the column named as product taken by this X is equals to 1, and Y as df, and just the product taken column only. So X is having all the feature columns, and this is my label column. That's what I've done here. So I would be simply asking it, please bring up those X and Y and just split my data, this particular ratio, let's say 25% to the test size, or maybe 20% to the test size, and remaining to the training site. Also, setting up a random seat here, that should be a random state variable actually, and it could be anything. Let's say I'm setting it as 100. Doesn't make difference as in if I choose 100, 150, 120 or any value. Actually, I just wanted to keep that as a fixed value. So what really happened out of this particular line? Let me just talk on this. We talk about the shape of my data, X actually, that became 34 columns, 4,888 rows. But as soon as I actually like split my data, it became like this. The training set has been 80% of the total data, that is 3910. So as my test set is the 20% of the remaining stuff, that is 978. And their respective labels are into the Y train and Y test. You could check it out. Y train dot shape is actually having 3910 entries and Y test is having 978 entries. So I have split it down my data. All I am interested in now is wanted to build up a machine learning model. And for that, we had the algorithm with us that is yet to get know. I mean, like, we haven't discussed it in detail yet. So let me just take you back to this particular thing. We were talking about decision trees. So how we really do it? It's like a process where we need to create the root node first up, and that could be done with the help of attribute selection measure. So these are the approach that are required when I say I'll be building up a decision tree, and that decision, that root node or like, the selection of attribute is done. Could be like various parameters there, but we will get to know a few here only. After that, we break it down and then we just break it down to the smaller data sets, and we'll be repeating this entire process until unless we get like all these similar entries in the particular group, or like there are no more instances that could be broken down. There could be like number of possibilities on which that conditions would be terminated. So we keep doing it, finding out the best attribute and then just topping it up. So what are the possibilities are there? I mean, like entropy, information gain, Kinney index, gain ratio, reduction in variance, and chi-square. So there are a lot of possibilities through which I could find out which attribute could be useful here. So in general, like what we do, like if I say a particular case, if I have mentioned it here, okay, when I talk about the information gain, we actually choose the attribute with the higher values. If I say information gain is like the more purity, I should say. While we use I mean, like this particular thing, information gain, we believe in like the attributes are supposed to be categorical. And if we go with the other attributes like Gini index, we assume the data has to be actually in continuous form. In our case, the majority of our data is categorical. So we might think of using this information gain or maybe the entropy actually. I'll tell you about it the very next slide. But this is how we decide on the factors, like what kind of, attribute selection measure we should be applying in the decision tree building up. So for categorical attributes, we go with IG, and for continuous attributes, we go with Gini index. So what are these terms all about? So firstly, we talk about the entropy. So entropy is something which talks about the impurity of our data. That means the higher the entropy, the harder to find out like the conclusive information out of something. Like here, I could see if somebody is going to play the golf, I mean, like yes or no, two possibilities out there. So if I try to find out the entropy of this, the entropy formula is actually given like this: probability of that particular parameter and logarithmic of the probability multiplied together, and the whole thing is like actually added with a negative sign over there. So if I do calculate the entropy for this particular case, I would be getting at 0.94. That's quite high actually. If it would have been like quite low, means if there would have been like values here, the majority 13 and 1 here only, I could have said like this would be going lower side, but not happening right now. So that's why I could say this is really hard to figure out like what is the conclusive thing out of this particular data. Similarly, if we have multiple parameters like we are having here in our tour package prediction, here we see like some outlook and play golf, as in like outlook is sunny, overcast, and rainy, and the play golf case is on this particular scenario. Then we calculate the entropy based on this particular formula, where we calculate the probability of the other parameter multiplied with the entropy of that parameter. So that is something would be something like this in this particular example, 0.69, which is comparatively lower. If I do say is going with single attribute, play golf. So this is how we just check it out, like which parameter is actually having, less entropy actually. If any parameter is having, I mean, like the one which is having the least entropy, we go with that. We say this is the best parameter from which I can start. Easy to make decisions on the basis of that. That's how we do it. And then comes like the counter version of the entropy, that is information gain. It also believes in the same factor, the entropy itself, but it's the, as I said, the complement of that. So that's also like talking about the more clarity on the data, less impurity, I should say. So in this particular case, right hand side we see high information gain and left hand side we see low information gain, because of here we see number of plus and minus are actually equal number. So as here, equality is not very important, but the thing is the randomness is quite high. But here we can see majority elements are positive, and here we see the majority elements are negative. So that's why we call it like this is having higher information gain. So the parameters having higher information gain can be chosen like upfront for the building of the trees. That's how we do it. So in simple words, we're supposed to find out the best attribute through these methods. There could be the other one, that is the Gini index, as I said. When I really work with the continuous data, that is also a kind of cost function. And this is something that is good when we have like larger data set. And higher the value of Gini actually tells us the higher the inequality, higher the heterogeneity. So we choose a parameter, for the splitting if it is having less Gini index. So these parameters, all these terms are meant for this particular thing that was named as decision tree here. To build up a tree, we needed to select, the parameter based on the approaches. And after the selection of the best parameter, we split down, then we further split it down, then we split until we just get into the final stage of our tree. And as soon as we are done with that, like we have already prepared our training data and created a decision tree stuff, then we just say my model is prepared, let's use that for the evaluation and justify if it is like trained good enough or not. So this is all what we'll be doing, guys. And I mean, like there are more things that could be coming up next, but first up, let's do on this particular case, like how we can really implement whatever I have said here. So for this, I would be asking it, please bring up the tree, and that is decision tree classifier right now. And then please create a model. Now all the things, all the lines that I have spoken up, they are just inside this one line decision tree classifier, and all I will be just hitting like fitting my training data into this. As soon as I hit this, it will be like applying all the parameters. And where are the parameters? Let me just show you. The parameters are actually having inside this particular class, it's algorithm class actually, the criterion. By default, this is going with the Gini index. As I could tell you, like there are information gain, entropy, and other parameters as well. So splitter is best, mixed depth is none, minimum sample split, minimum sample leave. So some parameters are there for sure. I could control those parameters, or like I can tune in those parameters for better results sometimes. That is what we will be talking up like the very last step. But right now, I would be simply thinking here, like applying it as it is. The criterion they have provided like Gini or entropy. So Gini is going to be for my categorical stuff, entropy is going for my continuous stuff. So I'll be going with the Gini right now. Let's not modify any of the parameter as of now and just hit that. Okay, I made a mistake. Let me check it out. What went wrong here? Hold on. I have just used the DF itself. I wanted to do that with DFI. So that was a mistake. Like we imputed data and stored that into DFI. So this was the thing I messed up. So I'm just doing it again. Nothing going to get changed, just the variable name I have used a different one. So my data got trained, and when I check it out, what sort of model be built up, it will be saying it's a decision tree classifier. So it is not meaningful to see this. Rather, I can ask it, can you just tell me how good my model is here? So the simplest approach of doing this, like you can find out the score. Please tell me the score of my model on my test data. It says it's 0.9. If I say like in percentage, then it is like 90.79%. And what if I it is training data, then it is going to be 100%. This is called the problem. Like on training set, it is showing 100% score. That's called overfitting. Overfitting is like a problem I was just showing you right here. When I trained my model, I provided it with some data, and the data actually having a lot of points, just like this green line that I've highlighted just now is actually what my decision tree has done there. It's just drawn a very typical line to just perfect fit on the given data points to segregate the blue points. But the practical scenario actually is like there are certain points. Let's say this one, this little red. It could be. Let me just take up a particular color. It could be the case. Points are in this side as well. So decision trees are something which actually tend to overfit because they will be breaking down the data unless they are like done to the very final stage of having one node at each leaf. So this is really a problematic situation, because in overfitting cases your score would be 100 on training set, but when you will be going with unseen data, it will be like showing you very low scores, and that's undesirable. So for this particular thing, we have got number of ways of handling this problem, but in this case I can talk up with a very particular approach, and that approach is what I'll be saying, like cross validation first up, or maybe the ensemble techniques. So firstly, I'll be going with the ensemble technique. Also, I'll be showing you one more thing, the result that I'm getting here. So from sklearn.metrics, please import the confusion matrix and the classification report. So I could just ask it, can you just tell me the model classification report on my test data and predicted results on my test data. So it says it's around this section. Like the precision for people actually going for the product, so as the recall is quite low, means my model is so much biased, it's not able to recognize if the person is really going to buy it or not. It would be like always saying it is not going to buy the product. So this is the problem I'm facing while training my model. It's having a lot of bias here. So I just thought of applying the different way. The first thing that I said, I can go with the ensemble technique, and one of the very common ensemble technique is the random forest, where we create number of decision trees and ask a model to perform the model training based on like a few parameters, not all the columns all together. Rather, it will be splitting down the data. So for this, I can just simply ask it from sklearn.ensemble import random forest classifier, and then I just call it model RF random forest classifier dot fit x train y train, and now I'm expecting some score for training data as well as testing data. RF score, training, and on testing both. That's like X test, Y test. Let's see what really comes out. Okay, that's still 100%. It's not improved. I mean, like the training is still getting overfit here. So I would be like, okay, it's not working up well. So I'll be thinking doing it the other approach, that could be the cross-validation approach. In this, I will be asking it, can you please do the model underscore selection and import grid search CV. That's like one of the approach in sklearn library that will be applying some number of different parameters on my model, and we'll just check out all the parameterization with a different set of data, and maybe then after we will be getting some better results. Why I'm not calling it better, because this is having a huge difference in training and testing data set. I mean, like scores 100% and this is less 91%. It should not be having much of difference. It could be better if I was like getting 91 and 92 here, 93 here, but having 191 is like very problematic situation. So I always wanted a training score and testing scores, around each other, not having this much of gap. So for decision tree classifier, I could just ask it from certain parameters. That is what we haven't tuned before, but now we'll think of doing it. Like here we could see the criterion splitter and all those things. So I'll just mention a few here. If you could try those up for me. As in criterion is the very first one, and I'm asking it, please try the Guinea and entropy both. Maybe this is going to affect. Then after, I could just ask it, can you just go with the mixed depth as well by using, let's say, range, let's say 10 to 15 plus none. I mean, like these are the possible cases I'm providing to it. So as I'm just asking it, can you just change up with the min sample leaves, minimum sample leaf, that decides the factor, like how many leaves will be required, at least if I want to split it down. So I would say, okay, let's try those combinations. Max leaf nodes. Let's do this much. And I might try with this min impurity decrease parameter. So all these parameters are fetched from that decision tree, approach itself, like from here itself. Minimum impurities, this decrease, max leaf nodes, the max features, and all the other things. Also, I could just set up the random state for a fixed parameter just to keep it like similar results every time. So just setting up the final thing here, just asking it, let's say 0.1, 0.0, or maybe like 0.05. So just ask it for the different values. I'm going very random here. with no much specific reasons behind it, just going for like, let's give it a try. So I've created a parameter dictionary here like this, having certain values. Now I'll create a model DT with cross validation. This is in tree classifier, random state having a fixed value, let's say 100, and then asking it, please create the model for decision tree with cross validation using this grid search CV, and that would require model DT and all the parameters with the cross validation factor, maybe some 5, I would say. And now it will create it for me. All I need now to train my model, and will be expecting it to do some effort for me. Maybe I'll be getting some better results. So I'll just ask it to please fetch up the time for me. So from date time import date time as DT. So just asking it because I wanted to print the time. DT dot now model CV dot fit X train Y train, and then once it is done, I would say DT dot now, and it will be printing elapsed time seconds. And score what I wanted. So it has to be 100 multiplied by model CV best estimator dot score with X test or Y test. So this is the test score, and so I've done the entire stuff all together. So we could wait for it. Training score. So let's see what really happens after this. Okay, I haven't created that model in DTCV actually. That's what I did, a wrong thing here. DTCV it is. Still having some errors. Probably the random state. It's not liking the random state value actually. Let's just change it. Still having some errors. Something wrong has been happening. Check. And some wrong key has been passed, I guess. Not about the random state actually. Let me check what wrong I did. Criterion that could be, yes. Is fine. Gimme and interpreters. Yeah. So what else wrong is here? It's another. Let me just check that again. Still showing the same stuff. So let's do this now first. What is really wrong in my model? The one dot keys. Could see I have mentioned criterion max depth. Okay, that was underscore. So this is what I've done wrong here. It was always underscore. Still showing the same issue, I guess. DT1 minimum sample leaf. Minimum sample leaf and max leaf nodes is fine. Okay, finally I could make that up. So ultimately we could run that cross validation process. It will be taking a lot of time because this is going to apply all the different possibilities on this, and as soon as it will be doing it, like we'll be getting definitely some sort of results. And like generally it takes less time, I mean like around 10 to 15 seconds, but sometimes it will be taking longer depending on the parameters that we have provided here. Like I've asked it for the Guinea and entropy both. Maybe I could avoid the entropy because I knew it, this is not going to work out. For categorical, the Guinea is the better one, but still I could just wait it. But yeah, we got the results, and that came in 41 seconds. And I again just missed one parameter. Let me just write that. Still not pure. Well, it hasn't worked out well here. We tried with different things. Probably we could just set up a few more stuff around. Like seems like I made a mistake in some data pre-processing probably, or maybe this is what we could get the best out of this. But anyway, like these are like the approaches we could definitely try and working up. I could go with further the bagging classifier, maybe boosting classifiers also, like here for improvement of a model. But yeah, like this is something we could do. Any one of you like having any sort of question in your mind on this particular thing, you can ask me up now.
Audience, please ask. Any questions, please? Hello. Yes, sir.
Yeah.
Sir, any real-time example is there? Extension of any healthcare and space domain systems, like real-time operations.
Actually, you're not audible to me clearly. Can you please repeat that? Okay.
Like while using Hello, I'm audible.
Yeah, now you are. You can just drop that in the chat box as well. I'm not like getting the clear voice from your side. So please drop it
Yes,
in the chat.
sir. But I means any real-time applications.
I'm really sorry, I'm not able to hear you clearly at all. Well, anyone of you like having any queries, you can put me in the chat box. Okay. So real-time application on space applications in healthcare domain definitely like I mean, when I like specifically talk about the healthcare, there are a lot of things here in like when I talk about decision trees and like the random forest algorithms itself, because they are the key techniques through which we do the classification thing. So I mean, predicting any kind of disease, like going with some scans. So we have faced like this particular thing, in the COVID scenarios. And even though like the efficacy of the vaccines, all these things are something like where we actually required some sort of computer intelligence to like reduce our efforts. So in such cases, the tree algorithms and the random forest, the ensemble techniques are like quite prominent and can be really helpful. I hope I could answer your question.
Hello, I'm audible. Yes, sir.
Yeah, please.
Sir, any real-time applications standing in the sense in the sense. Hello. How many audience?
Well, your voice just gets fade away like after just saying the hello. Actually, I was able to hear you.
I'm in that.
Are there any questions which you would like to ask Piyush sir? Any questions? Okay. So
Well,
it's
since yeah, please.
complete as of now. Piyush
Yeah,
sir?
it is done. Yeah, it is done from my side for today.
Okay, okay. Thank you, sir, for giving us a hands-on experience like how to use Kaggle and how to download the data and how to work with the data. Uh, so very nice experience for all of us. We will definitely do something. And like we are meeting tomorrow morning, है ना sir? Piyush sir?
Yeah. We are actually.
Okay, sir.
Yeah.
Thank you, sir.
Thank you
Thank you.
so much. Thank you so much.
So see you all tomorrow morning on the same time as the time given in the brochure. Thank you all. Have a good day. Thank you.